pandemic in town, and it's taking creators down a rabbit hole of corruption in a Massachusetts town. It strikes at the heart of bloggers, no matter podcaster or receiver. It can strike you like a Lexus, then you've got Karen Red River fever. While all the symptoms are quite acute, and you'll ask things differently by far, you will utter what if anything, or you'll be screaming outside back. You'll swear she said I hit him 3 times, while making butt dials as well. No matter how hard you try to fight it, you just can't unring that bell. So once you finally say I'll allow it, like Auntie built the darn diva, you'll find yourself behind that buffer zone, 'cause you got Karen Red River fever.
Karen River fever. Well, good, no one's here. Didn't you see that? Hi, replay crew. Didn't see a thing. I was not singing along. Hi, mateys. Good morning, and welcome. Welcome to Oh My Monday. Oh my. Oh my. I have questions. I have opinions. And I am blown away. When you don't have a life, so to speak, and you're OCD, and you cannot let things lie, you tend to do a lot of research and a lot of investigating and a lot of brain thinking. That's, yeah, I know. Kind of just does it. So, having watched a few other creators over the weekend and getting a different perspective, it brought up to me a few things that I had not picked up on. So, one of them being the medical examiner, the notes that she took through during the autopsy of John were redacted in the second trial completely. Apart from his name, they were blank. Why? Are we trying to hide the fact that he had injuries? Don't see the point. What? Don't see the point. You wanted to keep out the undetermined manner of death and then not call her, but then you call her and you make her present different evidence. And I think I didn't get a chance to look at the second one, but the first trial, she said it was a 3 centimeter lateral abrasion to the back of the skull. Whereas I think in the second one, I need to go and check it. Well, actually, I'll run it through my database. What actual length she stated in the second trial, because I think it was actually more like 1.5 to 2 centimeters. So there's some variations that I just need to clarify. And it also occurred to me that the let me bring it up for you before I get into the trial. Day 18. Lordy B. Is it nearly time for Battle of the Experts, or that's what we're calling it? I think it's battle of who I can pay to get the right answer, really. The answer that I'm looking for. Oh, bugger. I saved it in the wrong file type. Really? Come on. Surely not. Maybe I'll go in that way. Where are you? Come on. Back you come. Oh, all files. What did it save as? It's an MP4, yeah? Oh. Okay, Jody. All right, you asked for an image. I know, it's only early. Now it'll read it now. You get to ask for the right file. Okay, so these. Last week, actually from the first trial, seeing those marks on the back of John's hand, I instantly went to, yep, that's the first responders attempting to gain IV access for resuscitation purposes, yeah? But no, can't be. And I'll tell you why. John, okay, when he was found, he was in asystole. So that meant he was flatlined. Now, I have no doubt that that was the case for at least 3-4 hours. At least. So, but what happens even if he had just shut down? Your body has this mechanism where it has so many protective instinctual things that it does. Like it does it without thinking. So the first thing it will do is it will constrict all of that, all of your external blood vessels into your arms and legs, and it will divert that blood to your vital organs, being your brain and your heart. Okay, so why on earth would anybody or any first responder even attempt to gain IV access at the furthermost point of his peripheral upper body limb? Not even in the cubital fossa, in the elbow, where the biggest, easiest chance is. Why? They wouldn't. He had the intraosseous access in his left tibia, straight into the bone. So that, my dear friends, is not IV access. And it also tells me that had that been attempted, even if it was IV access, that would have been done whilst the heart was still beating, because there's bruising. If that was done whilst he was in asystole, there's no blood circulation, so it ain't going to bruise. So what does that tell me? Wasn't done by the first responders. Well, who the hell was it done by? Because that to me looks like 2 puncture wounds. Either he was bitten by a snake, could have been inverted. I don't know. There might have been one hiding in the tire of the Lexus. Who knows? But 2 puncture wounds like that, I don't know. What it tells me, like the first thing that came to my mind was that someone tried to revive him and resuscitate him before he was on the snow and failed, perhaps. I don't know. Was anyone in that house medically trying? Oh, there was a nurse there, wasn't there? What's her name? Was it Sarah Levinson? But then she would have had to have had IV stuff in her bag. Or she could have gone to get it. I don't know. I only just stumbled across this afternoon, so it's still going around, bumping around in the old matter up there. It's still beeping and bumping. It hasn't settled yet. So I will I'll stew on it a little longer. I've got some printouts and stuff to do as well. Because yes. All right. We shall get into it. Okie dokie. Day 18. Day 18. Far out.
All right, Mr. Lally, whenever you're ready.
Lally?
Morning, sir.
Entrevu.
Could you please introduce yourself to the jury, spelling your last name?
Yep, my name is Nick Bradford, Bradford.
Nick Bradford.
What do you do for work, sir?
I'm a
Hello,
DNA
Nick.
expert for Bode Technology
And where is Bode Technology located?
in Lorton, Virginia.
And where did you go to school, sir?
I went to school at Mercyhurst College in Erie, Pennsylvania for a bachelor in forensic biology and a master's in forensic molecular biology from the George Washington University in Washington, D.C.
And following your education, where did you go to work?
I started at Bode in about 2009.
And so did you work at Bode prior to your graduation?
Yes.
And how long have you worked there at Bode?
Since then, I spent 2 years at the Pennsylvania State Police at about 2021.
I'll be back.
And when you joined Bode Technologies, what was your position and title that you were initially hired for?
I was initially a DNA technician
And when did you become an analyst?
in 2014.
And what is the difference between a technician and an analyst?
The technicians operate the robotic equipment in the labs and assist with paperwork and various reagent duties and things like that.
And what does an analyst do?
An analyst analyzes the DNA evidence that's submitted from various police agencies from around the country. We come to court to testify and do statistical analysis of any comparisons that we might do.
Now, if you could, sir, please describe for the jury the training that you underwent initially as a technician.
As a technician, it was probably a few, maybe 2 or 3 months training process that involved various reading of the manuals for the robotics and various written and verbal exams.
Now, is there a continuing educational component at Bode?
Yes, for DNA analysts, we have proficiency testing twice a year. We have to do a certain number of hours of continuing education, so that would be things like conferences, things like that. And we have to do scientific literature reviews, so we have to keep up with scientific articles 4 times a year.
Now, if you could just expound a little as far as what exactly does that continuing educational component consist of, as far as the conferences and scientific literature review? What specific areas are you reviewing and going conferences on?
Yeah, so that would be areas specific to forensic DNA testing.
Now, how many analysts work at Bode?
Somewhere between 60 and 75, maybe.
If you could, please describe for the jury what kind of lab Bode is.
So Bode is a private DNA lab, and we take casework from various police agencies across the country, and we also have groups that work on international cases and things like that.
Now, you mentioned some of your work, bless you, is submitted from law enforcement agencies around the country. Is that the entirety of the work, or where does some of the other pieces come from?
Yeah, so like I said, some of it is international, and then we also do some research work as well.
Now, what type of analysis do you currently perform at Bode?
So I am part of the customized casework group. So we take generally one-off cases or smaller, more complex cases, and then we work through those.
Now, specifically with reference to DNA analysis, can you explain to the jury, first in sort of general terms, how is that analysis performed?
Yes, so for DNA analysis, what we're trying to do is obtain a DNA profile from a piece of evidence and then potentially compare that with a reference sample from a known individual.
Now, is the Bode lab accredited?
Yes,
And by whom is it accredited?
through the National Institute of Standards.
Now, within the Bode lab, are there certain steps that are taken to prevent against contamination?
Yes, so at every step of the testing process, we have positive and negative controls. The evidence room is a secure room, so only a handful of people have access to that room. And then everything that we would need to test, we would sign out, and that would be recorded on the chain of custody. The building itself is secure, so you need to swipe your badge to sign in. We wear protective equipment through all parts of the process. So we have gloves, goggles, lab coat, hair nets, masks. And after we write the reports, all of our results are reviewed prior to being reported.
Now, to that point, sir, is there a review process that your work and any analyst work undergoes at the Bode Labs?
Yes, so the final step would be a technical and an administrative review.
Now, can you describe that process as far as the technical review and review in general at Bode?
Yes, so we submit the case file with a report and all of our conclusions, and then another analyst goes through everything and makes sure that they agree with everything that we submitted.
I think you made reference to this a little earlier in your testimony, but as part of the accreditation process, do you undergo proficiency testing?
Yes, twice a year.
And can you explain to the jury that proficiency testing process?
Yes, so twice a year we get what's essentially a mock case submitted from an outside vendor that we treat as if it were an actual case. We go through and do all the testing that we would normally do, and then submit that back to the vendor, and they compare the.
Good morning. I've lost my Bible, my red folder that I keep the daily trial stuff in. Yeah, I can't find it for the life of me. I'm gonna have to wing it today. How are you, sweetheart? How's your mum? How's she doing? She's hopefully feeling a bit better. Ice, painkillers. Did you get some Huradoid? I know it sounds wrong, but it's the best thing, I swear. Yes. Oh, you're the first one in today. Excellent. Good. Good to hear. And hi, Angela and Christine. Thank you for popping in earlier on. Sorry I missed you. Hopefully you can catch a bit more on the replay, because there's some some things hitting fans. The proverbial. Okay, come on. And
the results to the known results of what they should be.
Now, what areas have you specifically undergone proficiency
I didn't tell
testing?
you what.
So everything that I am trained and signed off in.
In DNA specifically, is that correct?
Yes.
And have you successfully completed each of those proficiency tests that you've taken?
Yes.
Now, you made reference to this a little earlier, but can you explain to the jury what are positive and negative controls?
Right. So positive controls we use to make sure that the various testing steps that we're performing are working as we expect. So if we have a positive control, we would expect to see the DNA profile that we intend to see in that positive sample. Negative samples we use to make sure that there aren't any sources of contamination along the way. The chemicals that we're using aren't potentially contaminated, or that maybe samples were switched or something along the way.
Now, when you were assigned work within the DNA unit at Bode Technologies, where do you retrieve that item, or where do you retrieve those items physically from?
Yes, so those would be delivered to our secure evidence room, and then any testing performed, we would need to sign that out, and that would be recorded on the chain of custody.
Now, the secure evidence room, is that temperature controlled at all?
Yes, we have just basic climate control as well as freezers and refrigerators.
And the freezers, refrigerators are commonly referred to as cold storage. Is that correct?
Correct.
Oh,
Now,
really?
why is items of evidence stored in cold storage?
Certain items of evidence are stored cold because things like heat, UV light, and moisture can cause microbial activity or degrade the DNA. So we would not get the highest quality results that we would want.
Now, when you retrieve items from the cold storage or from the secured evidence room, how are those items packaged when you receive them for DNA testing?
So they're usually, however they're packed from, like, for example, the police agency that sends it to us, they'll pack them according to their guidelines and standards, and then they're sent to us and we store them in the freezer. And then when they're signed out on our end, we just have a basic container that we put them in to keep the case together.
Now, so what is DNA?
So DNA is basically the manual for a living organism. Most of the DNA is contained within the nucleus of every cell, or pretty much every cell. And it contains all the information that is needed to make an individual.
Now, is DNA the same in every cell of a person's body?
Yes.
And how many steps are included in DNA testing?
So forensic DNA testing, the testing that we did, there are basically 4 steps. So there's DNA extraction, quantification, amplification, and profile detection.
Now, can you describe for the jury what each of those steps are and sort of what they entail?
Yes. So DNA extraction is we are basically trying to separate out the DNA from everything else. So all the other parts of the cell or any other material that might be part of the evidence. So we're left with just the DNA. Next is quantification, and we are trying to figure out how much DNA we have to work with. The steps further down the line are calibrated to a certain amount of DNA input. If we add too much DNA, it can cause problems. So we need to know how much we have to work with. And then the next step is amplification. So this is when we take 20 to 25 different locations within the genome that we're interested in looking at. And we make millions and millions of copies of each of those locations.
Why would you do that?
And in each one of those copies, there's a fluorescent tag that's embedded into each one. So then that leads to the final step of profile detection, where we separate those fragments out by size, and that fluorescent tag allows us to identify those particular locations.
Now, sir, in January of 2024, were you assigned to perform some work on a lab case number, your Bode lab case number, CCA 2416-0023, pertaining to this defendant, Karen Reed?
Yes.
Now, you received those items for testing from the Massachusetts State Police Crime Laboratory, correct?
Correct.
Now, do you also, when you receive items from an outside agency, do you also receive a corresponding submitting agency case number from that agency?
Yes.
And in this case, that was Massachusetts State Police Crime Laboratory, lab number 22-02184. Is that correct?
Correct.
Now, what type of work were you assigned to do in this case?
So in this case, I was assigned to look at an extract that was submitted from the Massachusetts State Police Crime Lab, as well as a hair, and then 2 reference samples that were also submitted.
Now, could you explain to the jury the process that you used to analyze, in general terms, evidence in this case?
Yes. So generally, we follow that same process, with the exception of the extract that was submitted. Since the extraction process was already completed, we did not need to do that, and we could move straight to quantification. And then we did the entire process for the hair as well as the reference samples.
Now, you made brief reference to it a moment before, but was there a known standard that was done in this case?
Yes.
And did another analyst test and report the results from the known blood standard of John O'Keefe?
Correct.
And how was that done?
Yes. So the entirety of the testing was performed at the state lab, and they submitted the final profile to us for comparison.
Now, what is a DNA profile?
So a DNA profile is basically just a list of all the variants at those 24 or 25 different locations that we're interested in. And the entirety of those different variations are what makes a DNA profile individual or unique.
Now, as far as when you're looking or analyzing or examining a DNA profile, can you describe for the jury, what does it look like? What are you looking at?
So when we're looking at a DNA profile, it's essentially a graph with a series of peaks across the horizontal axis. And those correspond to the length of the DNA fragments that we amplified. And those are assigned a number based on the length of that fragment. And those numbers are what we refer to as the alleles. And those numbers are assembled into essentially a chart, and that's the DNA profile.
Now, he did testify last trial. So he was straight after Brian Gallerini, statement number 60 on day 24. So he is a prior.
Now, could you please describe to the jury the process of comparison between a known standard and an evidence sample?
Yes. So when we have an evidence sample, we need to compare it to a reference sample. And then, so what we do is we take those 2 tables that I mentioned, one from the evidence sample and one from the reference sample, and we put them next to each other and do a comparison to see if the reference profile is potentially part of the evidence profile. And then if the 2 are consistent, then we would need to do a statistical calculation to determine the strength of the match. For example, if 1 in every 3 people would be a potential match, then that's not very strong. So we need to we have to have some sort of mathematical weight to describe the potential match.
Now, if you could again, sir, explain to the jury, what was your role in the testing in this case?
Yes. So my role was to analyze the DNA profiles and then do the comparisons.
Now, what items specifically did you receive for DNA testing in this case?
So yes, like I mentioned, we received the hair, we received the 2 reference samples, we received an extract from a taillight, as well as the negative control that was associated with that. And then we also received a reference profile from the state lab.
Now, starting with what your lab has labeled as EO2, that has a corresponding State Police Crime Lab item number 3-1.1. Is that correct?
Correct.
And what was the description of that item, EO2 3-1.1?
So that was the extract of the sample from the passenger side taillight of the vehicle.
And was there any further description or of that vehicle as far as the plate number?
Yes, there was a plate number associated with it.
And do you recall what the plate number was?
So that would be 3GC684.
And did you receive 2 buckle samples identified as RO3 and RO4?
Yes.
And what was RO3 identified as?
So that was a buccal swab from Yuri Bogetic.
And what was RO4 identified as?
So that was a buccal swab from Michael Proctor.
And then that extract portion, that was the part that was labeled as EO2, is that correct?
Correct.
And can you please explain to the jury what an extract is?
So like I mentioned, an extract is essentially it's a tube with a small amount of liquid in it, and inside that liquid is the DNA that was extracted from the evidence sample.
Now, the known standard of Mr. John O'Keefe, that had an item number as well, is that correct?
Yes.
And what was that item number first from the Massachusetts State Police Crime Lab?
So that was 8-1.1.1.
And did your lab, Bode Technologies, have a corresponding item number associated with that known standard?
No, we just used the Massachusetts lab number for that.
And that known standard from John O'Keefe, did that appear to be a standard single source profile?
Yes.
And what is a single source profile?
So a single source profile is essentially a DNA profile from one individual, as opposed to a DNA profile that could be a mixture of multiple individuals.
Now, what does STR stand for?
Stands for short tandem repeat.
And can you please describe that short tandem repeat process for the jury?
Yeah, so like I mentioned, what we're doing with STR short tandem repeat testing is we're amplifying a number of locations in the genome, and then we're separating them out by size. Now, the reason we do that is because at the sort of at the DNA level, those regions of the genome have a series of genetic base pairs that repeats over and over again in sequence. So they're short tandem repeated DNA sequences. And the number of times that sequence repeats at that location is what we call the allele. So if the sequence repeated 5 times, we would call that allele 5. And that the summation of all those alleles is what makes the DNA profile.
And what is an SDR mix?
So are you referring to the computer program, StarMix?
Yes, StarMix, excuse me.
Yes, okay. Yeah, so when we're dealing with mixture profiles, so that would be DNA evidence profiles where more than one person's DNA is all mixed together. We need to be able to try to separate that out as best we can. We use a computer program called STRMix or StarMix, and that uses various mathematical calculations that allow us to make the best use of that mixture data that we can. And it allows us to run those statistical calculations to reference profiles as well.
Now, item EO2 from the passenger side taillight of the vehicle. What did you conclude as to that profile?
Yeah, so that was a mixture of 3 individuals, including at least 1 male.
Now, if you could, please sort of walk the jury through that process in making a profile comparison from the profile from the passenger side taillight of the defendant's vehicle and your other submitted samples.
Yes, so when we're using StarMix and we're doing a comparison, we have the StarMix output. And essentially what that's doing is we input, based on the DNA profile that we observe, the number of contributors that we would expect to be there. So in this case, we would say there were 3 individuals. So the StarMix software will break out those 3 different components and give probabilities to each different allele combination. So we would take the reference profile and then compare that to the output from the StarMix program to see if there's a potential inclusion.
Now, you mentioned a little bit about statistical calculations. How are those statistical calculations done?
Yes, so once we determine that there's a potential inclusion in the mixture, we will run what's called a likelihood ratio. So essentially what we're doing there is we're doing a likelihood ratio is we're comparing 2 different explanations for the evidence profile that we obtained. So one of those explanations would be that in this case, the DNA profile is a mixture of one of those reference samples that we're comparing and 2 unknown unrelated individuals. The other explanation would be that it was 3 unknown unrelated individuals. So we compare those 2 and we determine the ratio of which one is more likely.
Where do those statistical numbers or calculations, where do they come from?
So they're all based in the fact that we know how common the different alleles at each location are within the population. So we can do a lot of mathematics and figure out how rare or common different alleles might be.
Now, sir, in your comparison analysis between the taillight sample and the known standard from John O'Keefe, what conclusions did you make from your analysis or comparative analysis between those 2?
Between John O'Keefe and the mixture profile, John O'Keefe could not be excluded as a potential contributor to that mixture profile.
And as far as the statistical analysis, what, if anything, did you find with reference to that?
Yes, so we did, like I mentioned, that likelihood ratio, and in the case of it being a mixture of John O'Keefe and 2 unknown unrelated individuals, it would be 740 nonillion times more likely that it was a mixture of John O'Keefe and 2 unrelated individuals versus 3 unknown unrelated individuals.
So who are the other 2?
That number that you just referenced, as far as 740 nonillion times more likely.
Who are the other 2?
How many zeros are in the nonillion?
Nonillion is 30 zeros.
You should get a goat cow or horse and turn it loose in your yard.
Analysis supported a
Hello.
a strong support for inclusion.
I was
correct?
distracted.
Now, can you explain
Like,
to the
well, how do we get to horses? Hello, sweetheart. How you going? was printing out reports and stuff. So why don't we? You've been trying to beat the heat. Beat the heat. Did you see? My temperatures are 0 tonight. 0. It's aching joints. Hallelujah. Are you a weed whacker? You a weed whacker? I decided yesterday that I would get my blower vac out. I bought this really lightweight one for myself for Christmas because I can't break, and I hate leaves. I hate autumn. So I'm like, oh, cool, I'll get out and do that. I got 2 minutes into it, and the bloody battery died, didn't it? And I can't leave a job half done. So, yeah, Jodie's a little bit sore today. Oh, really? And would you believe it is what, mid-May? And I'm still having to water my garden because we haven't had hardly any rain for weeks. And the next lot's not due till, I think, Saturday. Yeah. What's that? Yeah. Yeah. So how far away from Steve are you? Because I wonder if that's affecting his internet. All right. I'll continue.
Jury, what that means as far as the strong support from
Eating my dinner.
Yes, so we have a chart that based on the likelihood ratio, so that 749 million number, based on the different numbers that we might get, we assign a verbal qualifier to that just to make it a little bit more user-friendly. So in this case, it would technically be very strong support for inclusion.
Now, in your comparison analysis between the taillight sample and the known standard from Yuri Buchanan, what conclusions did you make from your analysis of those?
So he could not be visually excluded based on just comparing the profile to the StarMix output. So we do the likelihood ratio to determine that, like I said, that likelihood ratio. So in this case, it was 46 million times more likely that it was 3 unknown unrelated individuals versus Yuri Buchanan and 2 unknown unrelated individuals. So that would be very strong support for exclusion.
And again, sir, if you could just expound a little, when you say very strong support for exclusion, what does that mean?
Again, we're just referring back to the verbal scale that we have as part of our reporting guidelines.
Now, in your comparison analysis between the taillight sample and the known standard from Michael Proctor, what conclusions did you make from your analysis there?
Yes, so he could not be visually excluded, again, based on that initial comparison. So we run the statistic, and it was 76,000 times more likely that it was 3 unknown unrelated individuals versus Michael Proctor and 2 unknown unrelated individuals. And that would be strong support for exclusion.
Are they copping it as well or not?
The comparative analysis between Trooper Proctor's DNA sample and the taillight sample, that was a strong support for exclusion, correct?
Correct.
Now, turning your attention to what your lab has labeled as EO1. That has a corresponding Massachusetts State Police Crime Laboratory item number of 3-6.1. Is that correct? Correct. And what was the description that was provided by the external submitting agency as far as that item?
So that was the shaft end of a hair from the exterior passenger side rear panel of that same plate number.
The ninja hair.
Now, as far as that, and I understand that your lab didn't do it, but you're familiar with the process as far as extracting a DNA profile from a hair, correct?
Yes.
Can you explain that process to the jury?
Yes. So during the extraction process, we dissolve the hair and then we attempt to do our normal DNA processing.
Now, what is different, if anything, in DNA testing when it comes to hair?
So hair, generally, if it's the hair shaft only, we would not expect to get great STR results. However, it is possible. So we usually attempt that first.
Now, are you familiar with the term follicular tissue?
Yes.
And can you please explain to the jury what that is?
Yeah, so that would be the
Right
hair
to the
follicle,
bottom.
and in the hair follicle, we would expect to find a lot of nuclear DNA. So that would be DNA from the nucleus of cells.
You mentioned there any sort of piece of hair. There's a root end and a shaft end, correct?
Correct.
And can you probably pretty well understood, but could you please explain to the jury the difference between the two?
Yeah, so the root end would be the end that we would expect to find the root or the follicle, and then the shaft end would be just the
pointy
shaft of
end.
the hair itself.
Now, what is autosomal DNA testing?
Yeah, so autosomal DNA testing. So autosomal DNA is the DNA that from mother and father that's combined in the child. So that would be opposed to DNA that's inherited directly from a single parent. So that would be something like Y chromosome DNA that would be inherited directly from the father. So all the sons of a father would have the same Y profile. Also, there's mitochondrial DNA. So the mitochondria exist outside the nucleus of the cell, and that is inherited directly from the mother. So all of a mother's children would have the same mitochondrial profile.
Now, sir, from your analysis, what were your conclusions for the hair, EO1, in your autosomal or SDR testing?
Yes, so we performed the extraction and then the quantification, and the quantification results were below the limit of detection. So we would not expect to get an STR profile from that hair.
And if you could expound just a bit as far as that term below the limit of detection, what exactly does that mean?
Yeah, so during the quantification process, our instruments are calibrated as part of our internal validations to detect a certain amount of DNA. And once we get below that amount of DNA, it's determined, we call that undetermined. So that would be below the instrument's limit of detection. And based on those validations, we would not expect to get a profile from that.
And so what happened with the hair extraction sample in your lab at Bode from there once you had completed the SDR testing?
Yes. So like I said, it's not unexpected that the shaft of a hair would not give us STR results. So we often transfer those to the mitochondrial group that does the mitochondrial DNA testing.
And why is that transferred from you to another analyst within the lab?
I'm not personally signed off in mitochondria. We don't do quite enough testing to have everyone signed off in all the different technologies.
Thank you very much. I have no further questions.
All right. Mr. Jackson?
Thank you, Your Honor. Good morning.
Good morning.
Quick questions. You mentioned, Mr. Bradford, a quantification related to both urobucanic and a known sample from former Trooper Michael Proctor. Can we go over? I'm going to ask you about the sample related to Michael Proctor. I think I heard you say 1 in 76,000, correct?
Yes.
Describe that one more time for the jurors. When you quantify that profile as it compares to the population of the Earth, for instance, what does that mean? What's the significance of 1 in 76,000?
Yes. So you need to be very careful when we're talking about statistics, because if we start to introduce different analogies to try to describe them, they start to go off the rails, and we're describing things that are not actually described in the statistic. So it makes a lot of sense to compare that to the population of the Earth, for example. However, what we're talking about here are the relative likelihoods of those two different explanations of the evidence profile. So like I said, in this case, it's 76,000 times more likely that we would observe that evidence profile if it were 3 unknown unrelated individuals, as opposed to Michael Proctor and then 2 unknown unrelated individuals.
And sometimes, Mr. Bradford, we get numbers that are just sort of mind-boggling. You said 30 zeros. What is that number again?
Nonillion.
Nonillion?
Nonillion, yes.
Y'all literally in your job, like, almost have to make up new numbers. Nonillion, none of us have ever heard of that. That's 1 followed by 30 zeros, correct?
Correct.
As opposed to 76,000, which is 76 followed by 3 zeros.
That was funny, wasn't
much
it?
smaller number by factors of
I did like that.
a nonillion, nearly, correct?
Correct.
So when you say that there's strong support for the exclusion of Michael Proctor in that DNA sample, you're not suggesting that he's completely excluded as a potential contributor.
Well, no, what I'm suggesting is what the numbers state, so that it's 76,000 times more likely that it were 3 unknown unrelated individuals versus Michael Proctor and 2 unknown unrelated individuals.
Understood. So you're not excluding him. You're simply saying statistically there's strong support for exclusion.
Teresa messaged me on Discord and asked me how my weekend was. Well, I'm having a good weekend. And I'm like, define good. And I said, how's yours? Wet and wild?